Alright, as promised, here's an example with finding the inverse. It's a little bit more complicated than the one we did in class. We're given the function f of x equals negative 2x over x minus 1. We want to find f inverse. So again, the process of finding f inverse is to begin writing the equation with y instead of f. We then want to flip-flop the x's and y's. So all the x's become y's, all the y's become x's. So in doing so, we get the equation x equals negative 2y over 2y minus 1. Sorry, not 2y, it should just be over y minus 1. Apologies. Now we're going to solve that equation for y. Well, we say, well, what kind of equation is it? Well, it's a fractional equation. So being a fractional equation, we have to multiply through by our common denominator. So doing so gives us x times y minus 1 equals negative 2y. And continuing to simplify, we'll have xy minus x is equal to a negative 2y. Now we want to solve this equation for y, but here we have x's and y's together and y's and numbers together. So what we do is group all the y's on one side, everything else on the other. Now it really doesn't matter which side you group to. I like things being positive, so I'm going to move the 2y over and get xy plus 2y. And then while I'm at it, take that minus x and move it to the other side. Now unfortunately we can't combine xy and 2y because they're not like terms. But what we can do is we can say, hey, y is common in both of those things. So let's factor the y out. So, and then we have y times x plus 2 equals x. And so finally, to solve for y, we divide by x plus 2. And so we get y is equal to x over x plus 2. And so that, my friends, is f inverse. So finally, the last thing we do is we just write down f inverse of x is equal to x over x plus 2. Now, part of the directions for some of the problems you did ask you to verify that that is in fact the inverse. Again, to verify that things are inverses, we have to now go back and compute f of f inverse and see if that becomes x, and then also f inverse of f and see if that's x. And that's what we're going to do here in just a second. Hey, come on in. Okay, now we're back, and first I do apologize for the little interruption as a student command. So here to verify, we need to do f of f inverse. So what I've done is I've taken my function f, which was negative 2x over x minus 1, negative 2x over x minus 1, and I have now replaced the x with f inverse as we found it, x over x plus 2. So I've went into my polynomial here, and I've now made that change. So then what we want to do is we say, okay, we need to simplify that. It's a complex fraction. So to do that, we multiply both top and bottom of that fraction by our common denominator, x plus 2. And so we proceed now to simplify. So in the first case, the x plus 2 goes away, and we'll just have negative 2 times x. In the bottom, the x plus 2 goes away, so we're left with just x. And then minus 1 times x plus 2. Okay, and then we just continue simplifying. So on the top, we're just left with negative 2x in the bottom, we'll have x minus 2, which gives us negative 2x over negative 2, and it gives us exactly what we were hoping to get, which is just x. So now I've done the verification just one way. I am going to not bother with the other way. I feel you've seen it the one way, you'll be able to do it the other way. But now what you would need to do to verify it the other way is then go back now and take f inverse of f of x. So take our f of x function, right here, f of x function, and plug it into our f inverse function over here. Okay, and you should come up with x, because these are in fact inverses of each other. So hopefully this will help you out as you get on and start looking at inverse functions. And good luck. See you later.